Hello everyone. Today our team will be presenting a design for a car chain, a decentralized blockchain application for buying and selling cars. Before we begin, our group would like to thank for guidance and support our academic and business advisors, Marco Morano, Richard Myers, and Hunter Gray from JP Morgan Chase, and our professor, Dr. Christensen. In today's presentation, we would like to cover the following points. We'll talk about the background, define the problem statement and requirements, present our design, as well as touch up on constraints, applicable standards, risks associated with the project. And in the end, we'll review major milestones and show how we plan to meet the requirements. A few words about how car purchases are made today. A new car is the second most expensive purchase for American consumers. Today, four parties are involved in a car buying process: a lender, a dealer, a buyer, and the state. During the process, information is being exchanged and verified. In the meantime, the buyer acts as a distrusted messenger. In the following diagram, you can see how purchasing process works now. The buyer first secures financing through the lender and brings a letter of credit to the dealer. The dealer verifies the letter of credit from the lender and transfers the vehicle, title, and the tag to the buyer. The buyer then must register title and tag with the Department of Motor Vehicles in their state and pay any registered tax.
So this leads us to our problem statement. How can the mutually distrusting parties involved in buying a car trust the information that they are given without validation? Also, how can the multi-stage process of buying a new car be consolidated into one cascading execution? From this problem statement, we have a couple of requirements. As a buyer, I want the institutions involved in buying my car to communicate with each other so that I am not expected to be the intermediary between them. For this requirement to be met, the lender, dealer, and state all need to be able to read and write a decentralized ledger. As a lender, I want to validate a buyer's line of credit one time so that I don't have to accept and validate every dealer query. For this to be acceptable, the lender publicly certifies one line of credit one time and writes it to the ledger. As a dealer, I want a quick way to validate the lender's line of credit so that I can sell my inventory quicker. The dealer can read the ledger in under a minute. As the state, I want a trusted ledger of ownership transactions so that I may keep an accurate registry of motor vehicle operators and owners. For this to be acceptable, ownership transfer is written to the ledger. Design. Our application will use free open source blockchain libraries and development environments, starting with Ganesh, a personal Ethereum blockchain which we'll use to run tests, execute commands, and see how our smart contract operates on a blockchain. Our application will be written in Solidity, an object-oriented language specifically made for writing smart contracts on Ethereum. Next, we'll use Truffle, a development environment, which we'll use to deploy and test our application. Finally, we will use MetaMask, a digital wallet, to store digital tokens that represent a car. Once all the source code is written and tested locally, it will be uploaded to an Ethereum virtual machine on the Ethereum network, allowing our users to participate in and execute smart contracts. Shown here is the new abridged workflow involved in buying a car using our blockchain application. First, the buyer secures financing through the lender, and the lender writes the letter of credit to the blockchain. Then, the buyer goes to the dealer, who reads the letter of credit off of the blockchain, and in exchange for that letter of credit, transfers a vehicle and a proof of ownership to the buyer. The buyer no longer has to register the vehicle with the state, as all ownership transactions are written to the ledger. The process is complete.
To look deeper into the technology, the blockchain technology is going to be made up of smart contracts, NFT for cards, transaction ledgers, and address of each parties. Smart contract is a contract that is programmed to execute certain functions based on preset conditions. NFT for cards is a non-fungible token that will help us identify and represent each card. Transaction ledgers the ledgers will have history of all the transactions that happened before. And the address of each user will show where and what got sent to each user. For the low-level design of our smart contract, it will hold letter of credit, proof of ownership, and state register. Only when all three documents are confirmed by each party and proved valid, it will execute the contract. Our constraints of the project. There is a time constraint where all project deliverables are due on Friday, April 30th at 5 p.m. Secondly, since we are creating a non-profitable project, there will be a cost constraint where the project should only be developed using free open source software. Thirdly, the time it takes for the whole process to finish should be less than the current process existing. And lastly, all the transactions should be secured and encrypted. For our applicable standards, there's a NASPAC format where Solidity contracts are fully annotated using NASPAC for all public interface. There's this ERC 7021 where our non-fungible token for our cards will be written in. And there is a elliptic curve digital signature algorithm where it encrypts the transaction process.
To understand risks in our project, we first have to classify risks. To classify risks, we have 5 probabilities from frequent to unlikely and 4 severities from catastrophic to negligible. Each combination of probability and severity has an own risk level. A catastrophic event with a probability of likely or higher has a risk level of extremely high. A critical event with an occasional probability has a risk level of high. A negligible event that is anything but frequent has a low risk level. In our project, we have identified the following risks. Absence in weekly team meetings due to time conflicts. This is caused by scheduling issues as not everyone is available at the same time. It occurs occasionally, but has negligible severity, leading to a risk level of low. It can be mitigated by recording the meeting minutes, recording the meetings themselves, or filling in other members after the meetings happen. Another risk is team members being unable to contribute. This is caused by members being either unwilling or unable to finish their allocated parts of the project. It is unlikely, as all members are committed to the project. It has moderate severity, but in reality it could have variable severity depending on the conditions, such as what parts of the project were dropped and by what members at what time. At this time, it is a low risk level and it can be mitigated by redistribution of missing work. It could cause delays in project completion times. A final risk is data storage failure. Project pieces such as source code, documents, or presentation files could be lost. This is catastrophic severity, as loss of code would require rewrites that take significant amounts of time to complete. This is a medium risk due to the severity, even though the probability is still unlikely. However, it can be mitigated by utilizing cloud storage to keep backups of all important documents. For our time frames and plans, our project has been broken up into the following time quanta. We've allocated 10 days to develop the requirements, which were due February 12th. The next 28 days past that are allocated to development. This is the current phase. After that, we will spend 10 days on testing in a local environment. Past the testing period, 13 days are allocated to fix issues discovered during testing. Once testing and subsequent fixes are developed, we will take 6 days to test on a simulated environment. Another 6 days past that will be used to review the simulated test and stabilize any outstanding abnormalities. The final 5 days will be preparation for launch, which will occur on the final day. This concludes our presentation. Thank you.